Welcome back to the Deep Dive. It is Friday, February 13th, 2026. And if you've been tracking the energy markets or, the automotive supply chain this week, you know the ground is literally shifted under our feet. And I'm not being metaphorical. We are talking about actual excavators moving dirt in northern France.
It's been a week, yeah. A week where the theoretical future finally slammed into industrial reality. We're usually here talking about white papers, maybe R&D announcements. Today we're looking at concrete, at steel, and a very, very aggressive timeline.
Exactly. We are talking about ProLogium. And for those of you who've been following the whole solid-state battery race, ProLogium, the heavyweight contender from Taiwan, well, as of this week, the gloves are off. They have officially broken ground on their first major gigafactory outside of Asia, in Dunkerque, France.
And this is so significant because we're moving past the lab bench phase. For years, solid-state batteries have been this sort of holy grail that was always 5 years away. But this groundbreaking in Dunkirk, ProLogium is basically saying the tech is ready. It's ready for mass commercialization.
That's the headline, for sure. But I want to peel back the layers here. Because if you look at the details, the location, the scale, the whole ecosystem, this is not just about a factory. This is about Europe trying to carve out some sovereignty in a supply chain that's, well, it's dominated by East Asia. And honestly, the logistical setup in Dunkirk is fascinating all by itself.
Oh, it's a masterclass in site selection.
Let's start there. Dunkirk. Historically, we know it for, World War II, the evacuation. But in 2026, it's trying to be the heart of a battery valley. So why did ProLogium choose this specific spot? It's got to be more than just tax incentives, though. I'm sure those helped.
Oh, the incentives from the France 2030 initiative, they definitely sweeten the deal, no question. But the real driver here is logistics and energy security. See, Dunkirk isn't just a port, it's an intermodal hub. You've got deep water access for raw materials coming in, but you also have heavy rail, major road networks, and even inland waterways. It connects you to the industrial heart of Europe.
Right, so if you're shipping these heavy battery packs to, say, automotive plants in Germany or somewhere else in France, you have options. You're not just stuck with trucks.
Precisely. But the real killer app of this location, if you will, it's the neighbor. The ProLogium site is practically sitting in the shadow of the Graveline's nuclear power plant.
Okay, this is the part that really caught my eye. We talk so much about green batteries, but manufacturing them is incredibly energy intensive. There's a real irony if you build a green battery using a grid that's, heavy on coal.
That's the exact problem they're solving here. By plugging into Gravlines, ProLogium gets a massive, stable, a base load supply of low-carbon electricity. It de-risks their energy costs, which is huge when you're running these high-temperature processes for ceramics. And it lets them stamp low carbon on the final product with actual data to back it up. That's critical for the new EU battery passport rules.
It's a very smart play. You shield yourself from gas price spikes, and you hit your decarbonization goals on day one.
Okay, let's talk timeline, because this is where the rubber meets the road. They aren't building the whole thing at once.
No, and that's a sign of maturity, really. It's a phased rollout. Phase 1, operations are slated to start in 2028, and they're starting with a capacity of about 0.8 gigawatt hours.
0.8, which, let's be honest, by modern standards, that's almost a pilot line. That's not fueling millions of cars.
It's modest, yes, but it's the validation phase. The ramp-up after that, though, is aggressive. By 2030, they're targeting 4 gigawatt hours. By 2032, they want to hit 12. And they've secured enough land and infrastructure to potentially expand all the way up to 48 gigawatt hours.
48 GWH. Now that is serious volume. That puts them in the same league as the major lithium-ion players. But this brings us to the tech. We should probably clarify what solid state actually means here, because that term gets thrown around a lot in marketing. ProLogium isn't just tweaking a normal battery, they're changing the chemistry completely. Correct. Specifically, they're producing what they call fourth-generation, all-inorganic, solid-state lithium-ceramic batteries.
Lithium-ceramic. Okay, so we're getting rid of liquid electrolyte altogether.
That's the key. In the battery in your laptop or your EV right now, ions move through a liquid solvent. That liquid, it's flammable, it degrades, and it limits how fast you can charge. ProLogium replaces that liquid with a solid ceramic separator.
The challenge there, historically, has always been the interface, right? Getting a solid to maintain perfect contact with another solid without it cracking or creating resistance. It's like trying to press two rocks together perfectly.
Exactly. That interface resistance has been the graveyard for a lot of battery startups, and this is where ProLogium's big claim comes in, their superfluidized mass production platform.
Superfluidized. Sounds like something out of a sci-fi novel. What does that actually mean for manufacturing?
Well, it's their proprietary method for bonding these layers together. They keep the exact details a trade secret, of course, but the implication is that they've solved that contact problem at speed. They're not hand assembling these in a lab. They have a process that flows, that's the fluidized part, which allows for roll-to-roll manufacturing, just like traditional batteries.
And this is important. They aren't just guessing that this will work. This isn't just a PowerPoint. They have a reference plant already running.
Yes, the Taiyuan Gigafactory in Taiwan, it's been operational since 2024. They've already produced over 600,000 cells there. That's their proof of concept. So they're essentially taking that Taiyuan blueprint and, copy pasting it to Dunkirk.
Yeah.
Bigger.
Which significantly reduces the execution risk. They're debugging the process in Taiwan, so
Right.
they don't have to in France.
That's the plan. Although, scaling from a few 100,000 cells to 48 GWh, that's a nonlinear challenge. Your supply chain management just becomes exponentially harder.
Speaking of supply chains, I want to zoom out a bit because while ProLogium was grabbing all the headlines in Europe this week, the energy trend report you shared shows the rest of the world wasn't exactly taking the week off. In fact, looking at the data from just February 10th to the 12th, it feels like the entire industry hit the go button at the same time.
It was a remarkable 72 hours for the global energy sector. It really was. We saw this flurry of activity that highlights how the market is. It's diverging. While ProLogium is pushing the high-tech, high-performance envelope in France, we saw very different kinds of moves in China and North Africa.
Let's start with North Africa. Tinci Materials. They announced a massive project in Morocco.
Right. Tinci is a huge player in electrolytes. They're investing about $280 million to build a plant in Morocco. Now, you have to ask yourself, why Morocco?
It's got to be proximity to Europe, right? It's the same logic as Dunkirk, just from the other side. Morocco has free trade agreements with both the U.S. and Europe.
Exactly. It's a nearshoring play. If you're a European automaker, you want your supply chain close. Tinci is setting up shop there to feed the European battery factories. It's the upstream piece of the ecosystem that ProLogium is building in Dunkirk. You can't build the batteries if you don't have the chemicals.
So you have the chemicals coming from Morocco, the assembly in France.
Okay.
But then you look at China, and the strategy seems to shift from localization to just massive scale.
Yeah.
You mentioned a project in Yibin by a company called Shenzhen Pengcheng Infinite.
This one really stopped me in my tracks. While we're here celebrating ProLogium aiming for 12 GWh by 2032, Pengcheng Infinite just broke ground on a 54 gigawatt-hour base for energy storage cells.
54. And that's specifically for energy storage, not cars.
Correct. This is for the grid, for solar farms, wind farms, grid stabilization. And this highlights this crucial split in the market. We used to think of batteries as one big thing. Now we're seeing a clear bifurcation. You have the performance track that's solid state, high density, expensive for premium EVs. That's ProLogium.
And then you have the utility track.
Exactly. The utility track is all about cost per kilowatt hour. It's about massive volume. That's what's happening in Yibin. They're building standard chemistries, but at a scale that just dwarfs the EV market. The bet is that the world needs cheap storage more than it needs light storage.
It's the difference between building a Ferrari engine and building a shipping container. Both are needed, but the engineering priorities are completely different.
And the chemistries are diversifying to match. Did you see the news about Lingpao Lithium in Fujian?
I did. A 1 billion RMB investment, about 4 GWh. But they weren't just doing lithium-ion, they're also targeting sodium-ion batteries.
Sodium-ion is the wild card here. We've talked about it before. Sodium is cheap, it's abundant, it works well in the cold. It's not energy dense enough for like a long-range Tesla, but for city cars, scooters, home backup, it's perfect.
And it breaks that reliance on lithium pricing. If lithium shoots up to $80,000 a ton again, the sodium guys just shrug and buy more salt.
Precisely. And in the very same week, we saw the Xuancheng group in Jiangsu moving into vanadium redox flow batteries. Again, a totally different technology. Flow batteries are these heavy tanks of liquid electrolytes. You'd never, ever put one in a car. But they can last for 20 years with basically zero degradation.
So if we step back and look at this whole picture, we've got ProLogium in France with ceramics, Tinci in Morocco with chemicals, massive grid storage in Yibin, sodium-ion in Fujian, flow batteries in Jiangsu. The narrative that one battery will rule them all is dead, isn't it?
It is effectively dead. We are entering the era of specialization. The 2010s were about trying to force lithium ion to do everything. The late 2020s will be about using the right chemistry for the right job, needs speed and range, solid state, need cheap grid backup, flow or iron phosphate, need a cheap city car, sodium.
And in the middle of all this tech divergence, there's a geopolitical layer with Dunkirk we have to talk about. The French government isn't just excited about the tech, they're excited about the passport.
The European sovereignty angle. It's the theme that keeps coming up in all the press releases from President Macron's office.
It's interesting phrasing. Made in Europe with a Taiwanese passport.
It's a very pragmatic compromise. Europe realized it lost the first battery race to China and Korea a decade ago. You can't just
Yeah.
catch up on the technology overnight. So the strategy is import the tech, but localize the production. Bring ProLogium here. Let them bring their IP, their superfluidized platform. But pour the concrete in Dunkirk and hire French engineers.
It builds resilience. We all saw it during the pandemic and with the recent shipping crises that relying on a single supply line from Asia is just dangerous for a whole continent's economy.
Exactly. If there's a flare-up in the South China Sea or a blockage in the Suez Canal, the assembly lines in Wolfsburg need to keep running. Having the battery factory a train right away in Dunkirk helps guarantee that.
It really feels like the industrialization of the Green Deal. It's moving from policy papers to actual physical infrastructure.
And that's the hardest part of the transition. Anyone can write a policy. Pouring billions of euros into the ground and training a workforce to handle ceramic electrolytes. That's where the real work happens.
And ProLogium still has to prove they can do it. It's one thing to run a pilot line in Taiwan where your R&D team is down the hall. It's another thing entirely to run a gigafactory halfway across the world in a different language, a different regulatory environment.
That is the execution risk. 2028 sounds far away, but in factory commissioning terms, it's basically tomorrow. They have to build the facility, install the equipment, qualify the line, get it certified by the automakers. It's a sprint.
But if they pull it off, they have a massive first-mover advantage in the European solid-state market.
They do. They'll be the ones setting the standard for everyone else to follow.
It's going to be absolutely fascinating to watch. We are witnessing the maturation of an entire industry. It's messy, it's capital intensive, and it is finally happening.
It is. And for you, the consumer, it eventually means better, safer, and hopefully cheaper electric vehicles. But we're in that messy construction phase right now.
Well, we will certainly be keeping a very close eye on the progress in Dunkirk and how all these other chemistries fight for their piece of the market.
Absolutely. The diversification of the battery market is probably the most underreported, important story of the year.
And that brings us to the end of this deep dive. I want to leave you with one thought to chew on. For years, we've all been asking, when will batteries get better? The answer, it seems, is that they aren't just getting better, they're getting different. The future isn't a single breakthrough, it's a menu of options.
A very crowded menu.
Indeed. Now, before we sign off, I just want to take a moment and do something important. We know you have a lot of choices for how you spend your time, what you listen to. The fact that you chose to spend the last 15 minutes or so with us digging into the logistics of Dunkirk and the nuances of ceramic electrolytes, it really does mean the world to us.
We genuinely appreciate it. Your curiosity is what drives this show. We try to connect the dots, but you're the ones doing the thinking. So, truly, thank you for listening, and thank you for trusting us to guide you through some of the noise.
We hope we told this story with the clarity it deserves. Keep analyzing, keep questioning, and we will see you on the next deep dive.
Goodbye, everyone.
Take care.